Okay, tape 30, we're going to look at exponents and scientific notation. Okay, on your notes, rules for exponents. So here's what they say. That if you have the same base and you're multiplying, then you add exponents. Now this is going to be so confusing when you're first learning. But listen to what it says. It says if I have 2 to the 3rd power and 2 to the 4th power, then I have 2 to the 7th power. You don't multiply these numbers down here. If these numbers are the same, then when you multiply, you only add the powers. If the bases are the same, that A is the base, that's the exponent. If the bases are the same when multiplying, bases are the same, you only add the exponents. Do not multiply the A's. Okay. What the X and Y is telling you is how many A's. So if I have A to the 3rd power and A to the 4th power, well, A to the 3rd power means A times A times A. That's how many A's you have. Over here you have 4A times A times A times A. So therefore you have 7 A times A times A times A times A times A times A. So when you're multiplying, bases are the same, add powers. When you have A to a power raised to a power, that's when you multiply. So if you have A to the 3rd power to the 4th power, then it's A to the 12th power. You multiply when you have this in parentheses. 3, this is a special one to memorize. A to the 0 power is equal to 1. 5 to the 0 is equal to 1. 7 to the 0 is equal to 1. 8 to the 0 is equal to 1. Any number except 0, any number except 0 to the 0 power is 1. Just memorize it. All right, let's look at the 3 other rules here, number 4, 5, and 6. And this one says, this is the important one with a lot of examples here that we're going to work, is if you have a negative power, what you do is move that down to the denominator and make it a positive power. If you have a number to a negative power, you move that down and make it to a positive power. In other words, you do the reciprocal of it to the positive power. Just memorize that. Okay? Just move it down or move it up. If you have something here with a negative power on the bottom, you can move it up and make it to a positive power. All right, rule number 5 says when you're dividing, you subtract powers. When you're dividing, you subtract power. Very confusing. What it says is if I have A to the 8th power over A to the 2nd power, then the answer is A to the 6th. I do not divide the powers. I subtract the powers. A to the 8th divided by A to the 2nd is A to the 6th. Subtract powers. Do not divide the A's. Do not divide the A's. You simply subtract the powers. And then 6 is similar to 2, rule 2, that says you multiply these in. So x times 1 is b to the x. X times 1, the power here of a is 1. If it's not written, it's a 1. So x times 1, x times 1, x times 1. If this had been an a squared in here, you'd have had a 2x here. You multiply the powers from rule 2. All right, now let's look at some statements to memorize in your mind. Okay. Remove parentheses. Move negative exponents. What that means is the rule number 4. So if you have a number to a negative exponent, then you move it up or down. And then rule 3 is simplify, okay? So remove parentheses first, then work with the exponents. Okay, now let's look at some examples. All right, looking at the examples. Big difference between these two. What this says is you have a minus this. So what you have is a minus 3 squared. The minus is not squared, just the 3. So the answer to this one is negative 9. Now 3 squared means 3 times 3. This number up here means you write this down that many times. So 3 squared means 3 times 3. If this had been 3 to the 5th, it would be 3 times 3 times 3 times 3 times 3 times 3. 5 of those. Okay. Do not multiply this together. This tells you how many of these you have. So this 3 times 3 is 9. This says that you have a minus 3 times a minus 3. You have a minus 3 this many times. So minus times a minus is a plus. So the answer to this problem is a plus 9. Big difference between those two. Do not let the minus be involved with the exponent when it's written this way. But if you have it this way in parentheses, then you have the minus there. Okay, and this is why one of the rules says remove parentheses first. That's what they're saying here, is to work with the parentheses. Okay. So it's this times this. Now, if I'd had the third power here, then this would have been a minus 3 again. So it'd be 3 times 3 times 3. That's 27. And then a minus times a minus times a minus is a minus. Okay. All right, be careful of that. Make sure you see the difference between this and putting the minus in parentheses. All right, next example. Here we have 2 to the minus 2 power and 3 to the minus 3 power. Okay, so this can be worked by saying 1 over 2 to the 2 power divided by 1 over 3 to the third power. And when you invert, and when you divide fractions, you invert and multiply. So that's 1 over 4 times 27 over 1. This would be 27. 3 times 3 times 3. Not 3 times 3, but 3 3's. So that's 27. So final answer on this one would be 27 over 4. Now, let me show you a little trick here. But be careful with it. Be careful. You cannot do what I'm going to show you now if you have addition or subtraction in the problem. But when you have negative powers, you can move these things across this division sign. We can move the 2 to the and change the sign, and we can move this negative up and change the sign. And now go work it, and you have 27 over 4. Same answer. Okay. Cannot do that if you have addition or subtraction in the problem. Okay. But if it's all multiplication division, that's all it is, then you can move it up and down and change the sign right here. All right, let's go to the next example. All right, now what you need to learn to do is you multiply numbers. This is a minus 1 times numbers times numbers. So that's a minus 6. Then you multiply the letters, x times x times x. Remember now, if you multiply x times x, you add powers. So that's 4 plus 3 plus 1. If there's not a number there, it's a 1. So you have x to the 8th power. Okay, remember now, x to the 4th means you have x 4 times. Here you have it 3 times. Here you have it 1. So what you have x times x times x, and it's just add the powers. the minus 1. Remember now, negative power says you move it down and then make that a positive power. Or move it up. If you have 1 over 5 to the minus 2 on the bottom, you can move that up to the positive 2 on top if you want to. Okay. As long as they're not adding, subtracting, addition, subtraction, fractions, then you can move things up and down, change the sign of the power. All right, let's look at the next example. Next example, we have x to the 6th over x to the minus 3. Two ways of working this. One would be x to the 6th over, and then move that down, remember. And now when you multiply and divide fractions, if you divide by fractions, invert and multiply. So this would be x to the 6th times x to the 3rd over 1, which is x to the 9th. Okay? Now, another way of working this would have been to use our shortcut rule to start with. We could just move the x to the 3 up. Just move this up and change it to a positive power. And now multiplying, you still get x to the 9th over 1. All right, next example. All right, when multiplying here, these are the same, then you just add exponents. Well, 3a plus 2a is 5a. That's all there is to it. Now please watch this. This is not in the notes. If you have 2 to the 3rd power times 3 to the 4th power, you do not use any of these rules. These bases must be the same. This must be the same thing down here. All right, next example. Okay, this is 2 to the 1st power. So our rule is it's 2 to the 4th, a to the 12th, b to the 8th. When you raise a power to a power, you multiply, you multiply, you multiply. Now your teacher may want you to rewrite this. This is just something you'll have to find out in your class. Teacher may want you to multiply this out and write it as 16. But the rule here, to remove the parentheses, you multiply powers and then you simplify if you need to simplify. All right, next example. Several ways of working this one. I'm going to show you one way that the notes kind of show, and I'll show you another one in a minute. Now what we can do is rewrite this as a to the 10th, and I'm going to move this down, a to the 9th, and I'm going to move this up, a to the 3rd. In other words, if I have a negative power, I can move it across the division sign. I better not have an addition in here. If I have an adding or subtracting sign, I can't do that. All right, then you go work it. This would then be a to the 13th and a to the 14th, which would be 1 over a. Okay, subtracting, you have 13 of them up here, 14 down here, so you have 1 left on the bottom. Okay. All right, now, another way of working this problem would have been this. Multiply these together to start with. This would be a to the 1st, and this would have been a to the 2nd. This is a to the 1st, a to the 2nd. So the rule is subtract powers. Okay? So when you're subtracting, you get 1 left on the bottom. There's more a's down here than you have up here, so your a is left on the bottom. Or, watch, A while ago we had a to the 13th over a to the 14th. If you subtract, you get a to the minus 1. What is a to the minus 1? Well, there it is. All right, so when you divide, you subtract powers. All right, next example. Now here's the example with that addition and subtraction in here. I move this down, and I move this down. So this is now 1/4 plus 1/9. And that's a completely different problem. You have to work these individually, separate. You cannot do all these little shortcut rules we're looking at. So now you just go add fractions, all right? So common denominator is 36. So you have 9 of those and 4 of those. So you have 13, 36. Okay, next example. All right, what's the rule here? Multiply power. So this is 7 times a minus 1, x times a plus 2, and x times a minus 1. Multiplying a minus 1 times a 1, a minus 1 times a minus 2, plus 2. A minus 1 times a 1 is a minus 1. All right, now what's our rule here? Well, the 7 goes down the bottom. Move it across, and that goes up. So our final answer is x to the 3rd over 7. All right. Next example. All right, remember now this is the first power. So it's a minus 3 to the minus 3 over 2 to the minus 3. So that's, and this is a minus 1, okay, to the minus 3. All right, so this is a minus 1. That's what this will give us. And then this, we can move down to 3 to the 3, and this up 2 to the 3. So our final answer is a negative 8/27. Now, watch. If this power, I don't care what's plus or minus, if this power is an odd power and you have a minus inside the parentheses, then your answer is going to be minus, because it's going to be that many minuses. So that's odd number of minuses in multiplication. The answer is minus. If that's an even number, then it's going to be plus. Right. Now, a shortcut method on this is this. If you have a negative power out here, you can change that to a positive power and flip this fraction over, okay? You can just flip that over and change that sign. Right. And now what you have is 3 minuses, so the answer is minus. 2 to the 3rd power, 2 times 2 times 2, it's 8. 3 to the 3rd power, 3 times 3 times 3, 27. Either way you want to go about it. Okay, next example. Now, the reason this one's put in here is to get this point across. The x can be moved down, but the 2 is not. It's going to stay there. That minus, now if I had that in parentheses, all of it would move down. But that minus just goes to the x. So the 2 stays on top and the x can be moved down. Let me inject another example. If I had 2 to the x to the minus 2 power, then that would be 1 over 2 to the x squared, which would be 1 over 4x squared. Okay. Now that's the difference between these two, all right? Just like the very first example I started out with in here. where we had a -3 squared and a -3 in parentheses squared. Okay, makes a big difference. Okay, let's look at the last example now, which is a complicated one. Just a big, long, but we can handle it. All right, so here we go. Remove parentheses. So this would be 3 to the plus 2, 3 to the plus 2, x to the -4, y to the 6th, multiply powers, okay? And then over here would be 4 to the -1, x to the +1, y to the -2. All over 2 to the -2, x to the -4, y to the -10. Now notice I threw away the parentheses here, but I didn't here because we've got to multiply these back together, so I wanted to keep those separate. All right, so here we go. Next step, let's get right here. So we have 3 squared, which is 9, times 1/4, times x to the -3, times y to the +4. Multiplying this x times that x, add powers, y times a y, add powers. Okay. On the bottom I have 1/4, okay, x to the -4, y to the -10. All right, so let's come over here now and do this. All right. This is 9/4, x to the 4, x to the 3, y to the 4th, y to the 10th, and 1/4. What I did is this x to the -3, move it down, x to the -4, move it up, y stays here, this y moves up. And now let's simplify. 9/4 divided by 1/4 is 9. Subtracting, get one of those. Adding, we get 14 of those. All right, let's go back to here and look at another way of doing this. So looking at the answer in this. If I subtract powers, a -3 minus a -4 is a +1. 4 minus a -10, 14. So if you'll just stay with your rules, you can work it, most of these problems you can work it 2 different ways, but just stay with your rules of either subtract powers or your negatives, you can move them across the division sign and change them to the opposite sign. Okay, this concludes this part of the tape. Okay, first example on scientific notation. We have the number 356. The way we write scientific notation is to move the decimal, and you don't have one here, but just understood to be at the end of the number. You move the decimal behind the first non-zero digit. Okay. Behind it. Now, how many places does it take to move this behind the 3? It takes 2. Therefore, scientific notation says you can rewrite it as 3.56 times 10 to the 2 power. That's not real clear here, but that's supposed to be a 2. It has a question mark. What do you write? Well, you put a 2 there. Times 10. Now, this number right here is going to be how many places you have to move the decimal place to get it behind the first non-zero number. All right, now it says the decimal was moved 2 places to the left, so our power of 10 is a +2. Okay. Positive. If we have to move it the other direction, it would be minus 2. Now let me say it one more time. How many places do we have to move the decimal place where it is to start to get it behind the first non-zero digit? 2 places. Therefore, it's times 10 to the second power. Let's look at the next example. All right, 7,800,000. Okay, how many places do we have to move it from here to get it? So there's 3, 4, 5, 6. To get it behind the first non-zero digit, we have to move it 6 places. Therefore, the answer is 7.8 times 10 to the 6. Okay, example 3. 0.00002686. Okay, we must move it to get to the right of the first non-zero digit. So we must move it to get to this side of the 2. So that's 1, 2, 3, 4, 5, 6 places. So it's 1, 2, 3, 4, 5, 6 places. Therefore, it is 2.686 times 10 to the minus 6. Now, look at the 2 examples, number 1 and number 3. And just pick up on this and know it. And here's what it is. If the number is bigger than 10, then this is going to be a plus power. If the number's less than 1, in other words, if it's point something, it's going to be a negative power. Just know that by just already instead of counting anything. So if the number's larger than 10, larger than 9 really, then it's going to be a positive power. If the number's a small number, 0.000, then it's going to be a negative power. All right, so let's look at example 4 now. And let's go the other way. Let's write it out. If we have 8.1 times 10 to the 4th, then we go this direction. Okay, so the number is 81,000. Now again, keep in mind the little shortcut concept I gave you. If this power is a positive 4, then the number is going to be big. It's going to be larger than 10. So it's got to be 81,000, not 0.00081. If it's a positive power, it's going to be a large number. All right, let's look at the last example, number 5. And look at its connection between 5 and 3. If it's a negative power, then it's going to be 0.00 something. Okay. So you move the decimal place 3 places. This tape is on the laws of exponents. So let's look at the first concept. First thing we need to understand is terminology. This is a raised to the x power. We call this part the base. We call this the exponent. We read it as 2 raised to the 4th power. Now what 2 to the 4th power means is we have 2 times 2 times 2 times 2. We have the base, and we multiply the base together this many factors, this many of these values. So 2 raised to the 4th power, or 2 to the 4th power, is
2 times 2 times 2 times 2. Now when you multiply that out, it equals 16. So a base raised to a power means then this base value times itself, times itself, times itself, times itself, so that you have that many factors of the value 2. Now some of the most common mistakes that many students make are these two examples here. This is read and worked as a negative 2, where the 2 is raised to the 4th power, not a minus raised to the 4th power. That's the mistake that too many students make. There's a difference between these two problems. This really means a negative and then 2 times 2 times 2 times 2. And so what we get here is a negative and then 2 times 2 times 2 times 2, which is a minus 16. Now this means when you put the 4th power to the parentheses, it means all of that is raised to the 4th power. So we now do a minus 2 times a minus 2 times a minus 2 times a minus 2. Minus times a minus is a plus, times a minus is a minus, times another minus is a plus. Or another rule is if you have an even number of minuses multiplied, the answer is plus. If you have an odd number, if you only have 1 minus or 3 minuses or 5 in multiplication, then the answer is negative. Pay attention to this again. This is 2 to the 4th power and then minus that, or a negative and then 2 to the 4th power. This is a negative 2 all raised to the 4th power. Watch out for that and be careful of it. All right, now let's look at the laws of exponents. So in your notes there, we'll start with the first rule or law of exponents. And it is when multiplying same bases, you add the exponents. So if I have this base raised to a power times the same base raised to a power, the answer is that base raised to the sum of the powers. You do not multiply the bases together. You simply, if this is the same base for both of these, you simply add the powers. For example, 2 raised to the 3rd power times 2 to the 4th power is 2 to the 7th power. You do not multiply the 2 times the 2. You don't come over and put a 4 here. And the reason of that is this. This is 3 2's. This is 2 times 2 times 2. That's 3 of those. Times 4 more of those. So that gives us 7 in all. This is 2 times 2 times 2. 3 of them. And then we have 4 of these. So we have 7. 2 times 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 2, which is 128. Say it over and over and over again before I get through this tape, is that when you multiply and the bases are the same, you simply add the exponents. You do not multiply the bases. Do not multiply these. Simply add the powers, and then that becomes 2 to the 7th power. Another example, 4 to the 5th power times 4 to the 3rd power is 4 to the 8th power. We simply add these powers. Add the powers. Do not multiply the bases. You simply write the base down raised to the sum of the powers. And that's a tremendous difference because 4 to the 8th power is 65,536. If we multiplied the 4s and had 16 to the 8th power, it would be a tremendous large number. Nowhere close to being the same answer. All right, next example here is a to the 1/2 times a to the 3/4 is a, and you add powers. So if we come in here and add 1/2 and 3/4, we get 1 1/4, okay, or 5/4, getting a common denominator. Multiplying by 2, we get 2 plus 3/4. Point is, base to a power times the same base to a power is the base raised to the sum of the powers. Not 2 to the 4th times 3 to the 5th is not 6 to the 20th. You do not multiply these together. You do not multiply these together. Now the correct answer to this would be 2 to the 4th power. You just come in here and work this out. Just go back and replace that with 16. And then come in here and replace 3 to the 5th power with 243. And then you just have to multiply those numbers together. There's no special rule to handle this case. The rules we're dealing with say that if we have the same base times the same base, then we get to add the powers. If the bases aren't the same, we do not get to use any of these rules. You have to go do just numbers. All right, let's look at the second law of exponents. And that's division. And that rule says that if I have a base raised to a power divided by the same base raised to a power, then I subtract powers. I just copy the base down and subtract powers. Example, 4 to the 10th divided by 4 to the 2nd power is 4 to the 8th power. Not 4 to the 5th. You don't divide anything in here. The rule says if you have a base raised to a power divided by the same base raised to a power, you write down the base and subtract the exponents. Okay, a to the 6th divided by a to the 2nd is a to the 4th. Subtract powers if the bases are the same. All right, now let's look at the next one here. When the denominator power is larger, what happens? This is 5 to the 3rd over 5 to the 9th. That's 5 to the minus 6. 3 minus 9 is a minus 6. Now we have a rule in math that says we never leave any answer with a negative exponent. So what we have to learn is how to switch this over. And that'll be one of the rules that we'll talk about in a minute. But let's look at how we could figure out why this is like this. This is 5 to the 3rd. That's 3 5s. And this is 9 5s. How many do I have it? 1, 2, 3, 6, 9. So one of these will divide out with one of these, one will divide out with one of these, one will divide out with one. And what do we have left on the bottom? Down here we had 3 of them up here and 9 of them here, so we'd have 6 left on the bottom. So that's telling us then that a base raised to a negative power is the same thing as 1 over the base raised to a positive power. We'll talk about that some more. All right, the next one is just an example of where you have to watch out for that minus sign. Remembering the one I talked to at the beginning. This is 4 squared, which is 16. The minus is not squared, so it's a minus 16. This is a minus 4 squared. So minus 4 times a minus 4 is a plus 16. And that gives us a negative 1. Okay. Now again, one that's commonly made by mistake made by a lot of students are things like this. 8 raised to the 6th power divided by 2 raised to the 3rd power is not, you do not divide the bases into the bases, and you don't subtract the powers. You don't do any of this. What you'd have to do is come back over and say 8 times 8 times 8 times 8 times 8 times 8 times 8 divided by 2 times 2 times 2 times 2. Just work the problem out. The rule is the bases must be the same or you don't use the rule. All right, let's look at the third law of exponents, or rule that we have. And this rule says that any number or letter besides 0, now 0 to the 0 power is not defined in algebra. So if this is not 0, this is not 0, anything else raised to the 0 power is equal to 1. Well, why? Well, here's why. 4 to the 5th power divided by 4 to the 5th power is the same thing as 4 to the 0 power, right? Bases are the same, subtract the powers. 5 minus 5 is 0. But 4 to the 5th power, when you multiply that out, is the same as this. And so what, if this number is the same as that and divides into it, it will equal to 1. So it's not just something that's made up. It's a reasoned process. It comes from Rule 2. What we've done is taken a base to a power and divided it by the same base to the same power. So kind of a statement that says anything divided by itself is 1. Any basic number divided by the same number is equal to 1. That is, of course, not 0 divided by 0. Okay? Another example, x cubed divided by x cubed is x to the 0 power, or x cubed divided by itself is 1. Now, let's look at the last two examples I have on this rule, and that is this. If I have all of something right here, an entire object raised to the 0 power, then all of that's equal to 1, because it says all of this is divided by itself. So that's equal to 1. But don't get caught up and get fouled up on something like this. The b is the only thing to the 0 power here. So the correct answer to this really is minus 2a. The b to the 0 becomes a 1. So don't foul up problems on exams and homework on this stuff. If all of this is raised to the 0 power, then all of it's 1. But if only a portion of it's to the 0 power, then just that portion is equal to 1. All right, so anything raised to 0 power is equal to 1, provided that base is not 0. Let's now look at the next example. And this is the one that I was talking about a while ago, a rule about negative powers. Now, the rule about negative powers says that a base raised to a negative power is 1 over the base raised to a positive power. All right, look at the example. A base 3 raised to a negative 2 is 1 over base 3 to a positive 2, which when you multiply out, it's 1 over 9. But the rule is that if you have a positive base raised to a negative power, the answer is 1 over that base raised to a positive power. Or another way that sometimes can be used is says you can just move this down. Just move this down and change it to a positive power. I'm going to show you where you have to be careful about that, but that's not a bad idea to remember. All right, here's the other example that covers what I've talked about before. 5 to the 3rd divided by 5 to the 6th is 5 to the minus 3. So what do we do with a base raised to a negative power? We write it as 1 over the base raised to a positive, same power. Or, in other words, here we have 3 of these. We have 5 times 5 times 5. And here we have 6 of these 5s. And so 1 divides out, 2 divides out, 3 of them divides out, and we have 3 of them left. So either way you want to think about it, just learn the rule. The rule says a base raised to a negative power is 1 over the base raised to a positive, same power. All right, let's look at a problem like this, a little more complicated problem, taking this one. And this is where I was saying that I want you to look at these two right now. The difference between these two is this is all multiplication and or division. All multiplication and or division. This has addition in it. Now, if it's all multiplication and or division, you can move things just up and down across the division sign. A to the minus 4 moves down to A to plus 4. 3 to the minus 7 moves up to 3 to the plus 7. B to the 5th stays where it is. B to the minus 2 moves up B to the plus 2. As long as long as it's all multiplication, division problem, you can move numbers, negative powers, up and down across the division sign. But if you have addition or subtraction in the problem, you cannot move these things across the division sign. What you have to do on something like this is make a complicated problem. This becomes 1 over a squared plus 1 over b cubed, all divided by 1 over c to the fourth. And that problem, you have to go get a common denominator, invert, multiply. It becomes a very complicated problem. So remember that. Two things on this rule. First of all, a base raised to a negative power is 1 over the base raised to a positive, same power. Or, if you have a division sign here, and this is all multiplication, division, then you may move negative powers across the division sign by just changing the sign of the power. It's an important rule. Remember that one. All right, let's look at the next example. The next rule is a power raised to a power. And this is the terminology you need to put in your mind, and you'll probably hear it from teachers and people when they discuss this. Power raised to a power. You multiply powers. Okay, so we have a base raised to power, and all of that raised to a power, then you simply multiply the powers. Example, 2 to the 5th power, all of that raised to the 3rd power is 2 to the 15th power. Now, this rule also only works when you have all multiplication and or division. This rule does not work if you have addition or subtraction in here. If anything inside this parenthesis is added or subtracted, this rule does not work. This rule does not work. This rule does not work. Do not raise powers to powers unless it's all multiplication and or division. Now, that is not a subtraction sign. That is a minus sign. You must know the difference. If I put that sign between here, it becomes a subtraction sign. When it's out in front, it's just a negative sign. All right, so the rule is if you raise a power to a power, you multiply the powers. So, let's do this one. What is a minus squared? Or 2 of them. Minus times a minus is a plus. All right, then 3, 2, and then I multiply the power, 3 to the 10th. 2 times the 2 is 4. 2 times the 4 is 8. And then if you wanted to work this out, you could multiply 3 times 3 times 3, have it 10 times and get that answer. All right, let's look at a little more complicated one. Have all of this raised to the minus 3 power. Well, if we used our rule that we had before, the rule 4 that says I could say 1 over all of this to the plus 3 power, that'd work. I could just say, right, 1 over all of this to the plus 3 power, that would work. But use this rule first, the new rule, Rule 5, that says raising powers to powers you multiply. So minus 3 times this 2 is a minus 6. Minus 3 times this 3 is a minus 9. Minus 3 times this is a minus 15. Minus 3 times this is a plus 12. And a minus 3 times this is a minus 6. Now, wait a minute. Let's go back. What do we do about the minus sign? Well, that's a minus 3 of these. Don't worry about the minus. It's really a minus 3 of these. So that's a minus times a minus times a minus. And so the answer is a minus. All right, so what do we do now? Well, we have 2 to the negative 6, so I'll move it down. We have x to the minus 9, so I'll move it down, make it a plus 9. We have y to the minus 15, I'll move it down, make it a plus 15. We have c to the minus 6, I'll move it up, make it to the plus 6. And the a to the 12th is positive, I leave it alone. I just leave it down there. And the minus is just the minus all that. Okay. All right, now let's look at example 6. All right, let's look at the last law of exponents, or rule, or whatever you want to call it. And that is the base raised to a fractional power. The base raised to a fractional power. Okay. Remember back in one of the other examples, I had an 8 to the 1/2 times an 8 to the 3/4 fractional powers. Well, the way we talk about these is we talk about them and we introduce now the word radicals. Okay. The denominator becomes the root of this base. The numerator becomes the power. Now think of that. The base raised to a fractional power, the denominator is the root of it, the numerator is the power of it. Now I want you to look at these two and pay attention. It can be done either way. It says that I can change a to the y root raised to the x power. Or we can say a is raised to the x power, and that answer, we want the y root of it. Well, that's not the way to do it. Almost all problems, that is not the way to do it. This is the way we will work the problem. We want to do the denominator root of the number and then take that answer, all of that answer, and raise it to the numerator power. For instance, 16 to the 3/4 power is the 4th root of 16 cubed. Well, what is 16 times 16 times... I don't know. I don't know what 16 times 16 times 16 is. It's actually 4,096. Well, what's the 4th root of 4,096? Well, I don't know that. But look how easy it is if we'll do this. The 4th root of 16 happens to be 2. The 4th root of 16 happens to be 2. Now, what does it mean by the 4th root? Let's talk about that for a minute. What is the square root of 9? Well, it's 3 times 3. It's what times itself gives me 9. Well, the cube root of 27 means what times what times what. 3 of them gives me 27. The cube root of 8 is 2, because 2 times 2 times 2, 3 of them gives me 8. So power, if I have 2 raised to the 5th power, it means I take 2 and multiply it with 5 of them. If I have the 5th root of a number, all right, for instance, the 5th root of 32, what number 5 times gives me 32? Well, 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 32 is 2, because 2 5 times is 32. So that's what root means. So let's go back here and look back at this one. So the 4th root of 16. What 4 times? What 4 times gives me 16? And the answer is 2. Then what is 2 raised to the 3rd power? 2 times 2 times 2, which is 8. All right, let's do the next example. 125 to the 4/3 power. What that means is the cube root of 125, all that raised to the 4th power. In other words, do the denominator, the root of the number first, and then raise it to that power. So what 3 times, what number can I write down here times itself? That'll give me 125, and the answer is 5. The cube root of 125 is 5, because 5 times 5 times 5, 3 of them, gives me 125. And almost all problems on exams and in college algebra books, you can pretty well just experiment with it. It's going to be the number 2, 3, 4, 5, 6, or 7, or sometimes a 9 or 11, but it's going to be numbers that you can pretty well do in your head if you'll just experiment with it. Or if you don't know the answer to that, try 3. 3 times 3 times 3, 27. No. 4 times 4 times 4 times, that's 60. No, that doesn't work. 5 times 5 times, that works. If it didn't work, then try 6. You can figure these out without a calculator, or even without pencil and paper. All right. Now, that's not the answer, though. Here we have the cube root of 125 is 5. We now have 5 raised to the 4th power. So 5 times 5 is 25, times 5 is 125, times 5 is 625. So the final answer to this problem is 625. Okay. But the point is if you have a fractional power, think of that root of that number and then take that answer and raise it to that power. So let's take this one. We want the cube root of a minus 27. What times itself gives us 27.